With vitamin C, you can have like 1,000, think about it, 1,000 milligram tablet that you take. And 1,000, think about 1,000 milligrams of something weighed out. That's what you just put into your body. Why did you take such a high dosage amount? Because what?
It doesn't like stay in your body. If you don't use it, it'll pass through.
Exactly. There is no way that your body is needing or requiring or demanding that much vitamin C. And there's no way that the body could absorb that much vitamin C. You're creating expensive urine because it's going to simply come out in your urine. Take too much of it for just a couple of days, it's going to give you diarrhea. So it's going to be coming out in many ways. Okay? So, fat soluble, however, those will store in the fat cells. Now, the fats that we have, the fats that we take in, the fats that the body is going to utilize. One of the biggest classes of molecules is the steroids. Now note, these are going to be the natural steroids, the ones that the body is going to make, the body's going to need. Their base molecule for every one of the steroids. Now think about it. Think about cholesterol, estrogen, testosterone. These are the steroids that come to your mind when you probably hear the term steroid. The base molecule is cholesterol. Cholesterol, how do we normally think about that term?
Clogging the veins.
High or low, clogging. Let's go with clogging arteries and vessels. Okay? Coronary disease. All that sort of stuff. Wait a minute. That's what we're talking about from our diet. All right? In the body's natural activities, cholesterol is needed. It is a structural component of the cell membrane, and it's the backbone molecule for our steroids that are natural. All right? For example, what do you notice about the structure of estrogen, testosterone, and the bile salts? Compared to cholesterol. At first glance, does it even look like there's any difference? First glance, you look at it and you're like, oh, okay. But if you begin to study it, you'll see that it's all based on 4 rings, okay, 4 structures. But you begin to see that in some of those structures, we have little circles show up, we have little lines show up, and then our functional groups begin to hang off at different points. But the base molecule is the same. 1, 1, 1, 1, 1, 1, 1, 1. And if you look at that for all of them, you begin to see, for example, from here to here, you see a ring. That lets you know the bonds that are existing between all of the C's, H's, O's, all that sort of stuff. If you look here, from here to here, you see that the lines are different. This is also telling you information about the bonds that are between all of those little elements. Over here, you can see that the chain is much longer than it is up here because the bonds got formed here. and some disappeared here. So cholesterol is an important molecule within the body. The fats of the body, the fat is going to surround and pad organs. This is extremely important. However, if you're ever told that, oh, you've got a fatty liver, that's not good. Okay, your health is not all that great. But under normal circumstances, fat is going to build up around the organs quickly. When you go on a diet, it's usually one of the first areas where the fat is lost, where the weight is lost. You might have lost weight for your first week. Well, let's don't look at the first week because so much that's the water weight and everything like that. But the second week, third week, you might be losing 2 pounds, pound, 2.5, whatever the case might be. And you're going, there's no different. It's being lost from around your organs first. So you might be losing weight, not seeing any results, but that's a good thing because it's getting lost from around your organs first. It's going to insulate parts of our body. Around our nerves, we have myelin. Not all of it, but for the most part, we've got myelin, which is a fatty substance that cushions and insulates the nerves. Because they do basically make these hormones, we're going to find that they can regulate processes within the body. Fat-soluble vitamins become important, some of them extremely important. For example, vitamin D. And vitamin D is going to help with calcium. Think about your bones, okay? For the structure, like I said, important parts of the cell membranes, energy, when they are pulled from the fat cells, the body can break them down into, and believe it or not, make it into a glucose molecule. The body can take a fat molecule and make a glucose. Go figure. It's pretty cool. Take a break. Be back at 3:30.